Good morning, everyone. Today we are going to talk about finding the area and perimeter using polynomials of different shapes. So today at home, I'm going to explain what you are doing throughout this worksheet. Okay, you are not doing the last page, which looks like this, exit slip and homework. We are doing that in class tomorrow. Please do not start that. Okay. This we are going to go through together, and I'll tell you which problems you're going to do on your own. So the first one asked me for the perimeter. Remember that the perimeter is adding up all the sides. Also remember that these are rectangles. So the area is length times width. The perimeter is 2L plus 2W. So 2 times the length plus 2 times the width. In other words, the sides opposite should be congruent. So if that's x plus 4, this should be x plus 4. If this is x plus 9, this should be x plus 9. So you could just add up all the sides knowing that, but this is the proper formula. So I'm going to do 2 times the length plus 2 times the width. I'm going to do some distribution here. So 2 times x is 2x. 2 times 9 is 18. 2 times x is 2x. And 2 times 4 is 8. Now I'm going to simplify. I'm going to combine like terms. So I have 2x and 2x gives me 4x. And 18 and 8 gives me 26. So this would be my perimeter of that shape. Area, I'm just multiplying. So x plus 9 times x plus 4, length times width. Take that first term, multiply it by the second parenthesis. Then take that second term, multiply it by that second parenthesis. So I'm going to do x times x to get x squared, x times 4 to get 4x. And then I have 9x here, and 9 times 4 gives me 36. Then I'm going to combine my like terms in the middle. I have 4x and 9x gives me x squared plus 13x plus 36, and that is the area. Now you are going to do, I'm going to call them problems 1, 2, 3. You're going to do those 3 on your own at home. Okay. In person, students will be doing those with me. Okay. So you're doing 1, 2, and 3 on your own, and I can talk about answers tomorrow if you want to see if you got them right. Okay. On the next page, we have the problems where I am trying to find the difference in the areas. In other words, pretend that this is a shaded region, right? If this is shaded, I'm trying to figure out what the area of the shaded region is. So I'm finding the area of the inner, the area of the outer, and then I'm finding the difference. So the area of the large rectangle is this length times width. So I have 3x times 9x squared plus 7x minus 12. So I'm going to distribute. That's going to give me 27x to the power of 3. I'm adding those exponents 1 and 2. That's going to give me 3x times 7x is going to give me 21x squared. And then lastly, 3x times negative 12 is going to give me negative 36x. This is in standard form. There's nothing else I can do here for that area. Now I'm going to find the area of the small rectangle. So once again, length times width. So I have 4 times 4x squared minus 3x plus 7. Distribute here. That gives me 16x squared minus 12x and plus 28. This, once again, is in standard form. Now, the difference is that subtraction. So I want to take that larger rectangle, 27x cubed plus 21x squared minus 36x, and I want to take away, subtract that smaller rectangle. Now, in order to do that, I'm going to change all the signs of the smaller rectangle. Just want to make sure I'm still recording. Perfect. So I'm going to change all the signs of this one. I rewrote the first one, changing the signs of the second one that I'm subtracting. So that's a positive 16x squared. I'm going to make that a negative. That's a negative, so I'm going to make it a positive. Positive, so I'm going to make it a negative. Now I'm just going to combine my like terms. So my largest exponent here is the power of 3, so that's going to come first, and it's by itself. It has no like terms. Then I can combine this 21x squared and negative 16x squared. That's going to simplify to be positive 5x squared. Then I have this negative 36x and positive 12x. That's going to give me a negative 24x. And then that negative 28 has no like terms, so I just bring it down. This is the area of this shaded area, the shaded region. It's also just the difference of me doing large rectangle minus small rectangle. So I'm going to call these problems 4 and 5. 4, 5. I want you guys to try those at home as well. And you're uploading a photo of the work of all these. Okay. All right. Moving on to the last page here. I'm going to do all 3 of these. I'm going to touch kind of quickly on the last one. I'm actually not going to do the last one. I don't really plan on giving you anything that crazy. I'll work with the setup. I'll help you with the setup, but I'm not going to have you actually multiply it out. You can try it at home if you want, and I can show the answer at the end of the video. But I'm just going to help you set it up. I'm not going to expect an answer on that one. So this first one says, if the triangle's perimeter is this expression, what is the length of the third side? So we're looking for this side. We know that all 3 of them should add to equal that perimeter. So if I know 2 out of the 3 sides and I have that perimeter, I'm just going to take the perimeter and I'm going to subtract from it the 6x minus 5, and so I'm going to take away 6x minus 5 and 9x squared plus 3x minus 8. That should give me the third side if I subtract both of these. Now remember, when we subtract, okay, I'm going to keep this here. When we subtract, we leave the first one the same, and then the 2 things we're subtracting, we change the sign. So I'm going to change this positive 6x to a negative 6x, negative 5 to a positive 5, positive 9x squared to a negative 9x squared, positive 3x to a negative 3x, and negative 8 to a positive 8. Now I have this long polynomial that I can change the signs, that I can combine like terms. So my largest exponent here is that power 2, so I'm going to combine those first. 13 minus 9, that's going to give me 4x squared. And then I'm going to cross those out to know I've taken care of them. Next, I have that power of 1. I have 2, negative 6, and negative 3. So that's going to be 2 minus 9. That's going to be negative 7x. And then I have negative 16 plus 5 plus 8. So I have negative 16 plus 5. That's going to give me negative 11 plus 8 is going to give me negative 3. Okay, so that would be my final answer for the third side. If I wanted to check my answer, I could take this one, add it with these 2, and see if I get this. Okay. Finding the area of this shaded region, this is a little bit of a challenge problem. So if you look here, they're giving you that this width is x, and this length is 3x plus 1. They wrote it right here. So I'm going to find the area of one of these boxes, and then I'm going to multiply it by 3 because there are 3 boxes. So the area for one of them is x times 3x plus 1. So if I distribute there, that would be 3x squared plus x. Now I'm going to multiply this by 3 because there's 1, 2, 3 boxes. So then I'll have the area of everything in white in here. So that's 9x squared plus 3x. So this is the area of the white boxes combined. okay? Now, just like before when we did this, the big box minus the small box, same thing. I'm doing the big rectangle minus those white pieces so I can get that shaded area left. So I want the area of the big rectangle now, so that's 10x minus 7 times 4x plus 3. So I'm going to do 10x times that second parenthesis minus 7 times that second parenthesis. So this is going to give me 40x squared plus 30x negative 28x minus 21. Now I'm going to combine like terms in the middle. I got 40x squared plus 2x minus 21. So this is the large area. So now I'm just going to subtract the large area minus the area of the white boxes, very similar to what we did on the last page. So remember to subtract, I'm going to rewrite the larger one, and then I'm changing the sign of what I'm subtracting. So that's going to become a negative 9x squared and a negative 3x. Now I'm going to combine like terms. I got 40x squared minus 9x squared. That's going to be 31x squared. I have 2x minus 3x, that's negative x, and then that negative 2 comes down. So this would be the area of my shaded region. Am I missing it? Oh, that's a 21, sorry. There's a 1 here. All right, the last one here, I'm just going to help you guys set this up. I'm not going to go too far into it. We'll do similar problems to this, but in this problem, there's an x and a y, so it gets a little crazy. I probably won't give you one with an x and a y in the future, but I'll go through it. So they're giving us this swimming pool. It's 18 feet by 36 feet. So this is 36, this is 18, okay? It's surrounded by a concrete sidewalk, so that's the white. The sidewalk is x by x. So the width here on the sidewalk is all the value of x. And then there's a planting area around in green, and this width is all y. So I need to figure out how I would go about fencing in this whole area. So the green, white, and blue all included here. Okay. So when I look at this, I want to know what this length would be and what this length would be. So this length here, or width actually, would have a y here for the green, then an x here for the white, and then this distance is 18, and then we have another x for the white and another y for the green. So now I have to add that all up. So I have 18 plus 2 x's, so that's 2x, and 2 y's. Okay. Then if I look at this side, I have the blue. Well, first I have the green, which is y. Then I have the white, which is x. Then the length of the blue is that 36. Then I have another x and another y. So here I would have 36 plus 2x plus 2y. So you're just adding all those little pieces, all those little lengths together. So now to solve this, I would be doing 18 plus 2x plus 2y times this length, 36 plus 2x plus 2y. This is a doozy to distribute everything, and I kind of need a little more room. So I'll just kind of show you how I started to distribute this. So here's what I had. I took the 18 first, multiplied it by that whole trinomial, second trinomial. Then I took the 2x, multiplied it by that whole second trinomial. And then I took the 2y, multiplied it by that whole second trinomial. As you can see, this was a lot of distribution, okay? And my final answer ended up with values of x squared, y squared, xy. So anything that was xy, I combined. The x squared and y squared, I could not combine anything. Okay, and those came in front, then the xy, because these all have a degree of 2. So I just have them in alphabetical. And then I did have some like terms I could combine for x and y, and then my 648 was alone. So this would be the area of if we put a fence around the whole thing. Now you couldn't give me an exact number unless we could name X and Y. For now, you can just give me polynomials. When we get into factoring next month, you'll be able to give me exact values for problems like this. All right, so just to reiterate, you are not doing this last page that looks like this, exit slip and homework. You are not doing that at home. Okay, the things you are doing at home, problems 1, 2, 3, and 4, 5 that I labeled. Okay, the rest of the problems from the notes I did with you, that's all you're trying on your own at home, and we can recap them tomorrow. All right, have a wonderful Tuesday or Thursday if you're watching this then.